Is truss collapse your worst nightmare? Ron StageMaster, safety above all. Hanging tons of sound and lighting equipment above spectators and performers is a serious matter. Scientifically, each time there are more than 2 hoists on a truss, or more than 3 hoists in a structure, there will occur the phenomenon known as statically indeterminate structure, which results in unpredictable load distribution. In most cases, this will cause load imbalance, where some of the hoists may reach overload, while others carry only a small part of the load. Experimentally, it has been shown that even if a structure visually seems balanced, it does not imply that it has a balanced load distribution, in turn resulting in some of the hoists ending up overloaded, in extreme cases even severely so. Thus, overload situations might happen to the most experienced riggers, even if each hanging point's load is calculated and the calculation falls within the limitations of the nominal hoist and truss capacity. The actual load distribution on the truss is still unpredictable and cannot be calculated or even estimated, which in turn might cause an overload situation. In real life, the rigger doesn't have a pause button. In its January 2007 meeting, ESTA Task Group on Chain Hoist Usage decided to have its member, Eilon Engineering, conduct an experiment aimed at measuring loads and load distributions that occur in day-to-day stage rigging scenarios. On March 5, 2007, an experiment was conducted by Eilon Engineering. The purpose of the experiment was to check the forces and loads involved in acrobatic shows and in lifting and hanging sound and lighting equipment for entertainment purposes. The experiment was conducted in the presence of Bill Sepsis of Sepsis Rigging Installations, USA, and with a special system which enables 25 measurements per second. Experiment 1. A structure of 1 truss with 3 loads and 3 hoists. Experienced rigging personnel attempted to level and balance the truss. When using the load cells, we could see that the attempts to balance the truss visually resulted in random balancing and imbalanced load division on the hoists. We also noticed that the slightest operation of one of the hoists, even for a fraction of a second, resulted in the addition of hundreds of pounds, while the truss still appeared to be balanced. Conclusion? A visually balanced structure is likely to have imbalanced load division, and some of the hoists might even be overloaded. Experiment 2. A mother grid structure was erected. The upper grid was suspended from the ceiling by 4 identical chain hoists simultaneously controlled by 1 switch. 1 load cell was hung in line with each of the 4 hoists. An identical arrangement of grid, hoists, and load cells was suspended from this upper grid. In the experiment, a slight change in the weight of the loads on the lower grid triggered a practically incalculable change exhibited by the load cells. Conclusion? On a mother grid structure, any changes in the lower grid load or load distribution will usually change the load values and distribution on the upper grid, which in turn might cause an overload situation. Experiment 3. Measurement of dynamic loads involved in an aerial acrobatic performance. The load cells recorded a maximum of 237% of the acrobat's self-weight. Conclusion: significant dynamic loads are involved in aerial acrobatics. Experiment 4. Measurement of dynamic loads involved in lifting a load with a hoist and stopping the hoist's operation. This test was conducted with both 50 feet, 16 meter per minute, and 14 feet, 4 meter per minute hoists. With the 14 feet 4 meter per minute hoist, the load cells recorded a maximum measurement of 120% of the load's weight. With the 50 feet 16 meter per minute hoist, the load cells recorded a maximum measurement of 180% of the load's weight. Conclusion: dynamic loads exist when starting or stopping the hoist's operation. The faster the hoist, the larger the dynamic forces.
You are looking at a video that shows the Ron StageMaster wireless load cell system, implemented on the McDonald's Global Production at the Orange County Convention Center in Orlando, Florida, in April of 2008. The set consisted of two 3,500-pound Matrix video walls, 4 LED video walls, each at approximately 1,200 pounds, one sheer drape and one velour drape, all of which were on travelers. When closed, the total concentrated load was approximately 21,000 pounds. A relief grid was installed to help disperse the load out and away from the 30 by 30 foot bay that all load points were suspended under due to the building's structural steel limitations. Notice how the Ron StageMaster system monitors the dynamic loads of the video walls in real time as they move off and on stage. This system was the added safety factor that we have been looking for in our industry for a long time.
Eilon Engineering has undertaken to harness our engineers' 3 decades of leadership in the industrial load cell industry to develop and launch a reliable, user-friendly platform to boost the rigger's performance, especially in preventing stage accidents due to overload. We are now proud to introduce the Ron StageMaster, completely wireless multi-load cell system for load monitoring and overload prevention. The Ron StageMaster is comprised of 3 components: the load cells, central receiver, and PC software. The load cells. The Ron StageMaster load cell embodies the technical know-how and the field experience that has been acquired from the sale of thousands of Ron industrial crane scales over 3 decades now. Installing these wireless load cells onto the hoists is quick and easy. No messy cables for the wireless models and single main wire for the wired model. The load cell is made of high-quality aerospace steel and is available in 2 safety factors, 5:1 and 10:1. It is available in standard capacities of 1 to 5 tons. Higher capacities are available, and in sets of up to 24 load cells per frequency, and up to 4 different frequencies, with system maximum total of 96 wireless load cells. Number of load cells. Ron StageMaster 7000 Wireless Premium, up to 96 wireless load cells on one screen. Ron StageMaster 6000 Wireless, up to 24 wireless load cells on one screen. Ron StageMaster 5000 Single Wire, up to 256 load cells with single main wire. The wireless Ron StageMaster 7000 may be integrated with the single-wire Ron StageMaster 5000 and together monitor on one screen a total of up to 328 load cells, 72 wireless load cells, and 256 load cells on single wire. The load cell shackle holes are shaped to have a 90-degree angle between their axes in order to eliminate external movement's influence which might cause inaccuracies. The battery life of this load cell is up to 1,500 hours on common disposable batteries, with optional 110-220 VAC operations. Another distinguishing feature of the Ron StageMaster load cell is its exceptionally small dimension that provides low headroom loss and easy portability. For example, headroom loss of the 2-ton load cell with 10:1 safety factor is 4.2 inches, 105 millimeters. The central receiver. The receiver has an RF reception range from the load cells of up to 450 feet, 150 meters. The PC software. In addition to being the first wireless stage load monitoring system, the Ron StageMaster is also the first to overlay the load distribution map on a grid plan preloaded from programs such as AutoCAD. This easy-to-install Windows 2000 compatible software provides a real-time simultaneous load measurement, including overload and underload detection. It offers user-defined set points for overload and underload detection of individual hanging points, user-defined groups of hanging points, and of the entire structure. Each set point can be used for a variety of purposes, such as setting off an alarm and stopping the hoists using any controller currently available on the market. Logical zoom-in and zoom-out features enable the operator to quickly spot specific load cells in groups. Optional features include real-time cellular text message (SMS) alert on overload occurrence and customized PDA for on-the-go load monitoring. It is therefore an innovative tool to unburden the rigor of the stress involved in overload prevention without knowing the actual load values and distribution. In addition, from a risk management perspective, the Ron StageMaster may justify rigor's request for lower liability insurance premium. Here is a summary of the main screens. Settings. Using this screen, you determine which load cell will belong in what group and assign a customized overload value for each load cell. This screen enables you to drag and drop the load cells onto the underlaid grid plan according to their physical location on the structure. This feature enables the rigger to immediately identify exactly where the problem is located on the stage structure. The next screen is used to assign group names to associate the load cells with the group functionality or location, for example, speakers, east upper truss, etc. Using this screen, you set customized group overload values. Weight control. This is the main screen that displays simultaneously in real time load values and distribution map. In addition, it will show important group data such as the sum, max, name, tear, zero, and situations such as overload and danger. Reports. Ron StageMaster has a powerful report generator of downloadable data log of months of continuous measurements, as well as all instances of overload and danger, that is easily transferable to any database software. Remember the near accident that we showed at the beginning? Now you have the tool that enables you to spot any undesirable load distribution the moment it begins to be dangerous, and immediately take corrective measures by stopping the hoist and, more importantly, using the load map to determine how to best rebalance the load distribution. Ron StageMaster can be added to any existing hoist and hoist control system. Ron StageMaster systems were recently deployed in important projects such as Human Castel Barcelona, Casa de Música, Porto, Munich Olympia Park, Boston Symphony Orchestra, Esplanade Theaters on the Bay in Singapore, and more. And in the largest world tours such as AC/DC, and the European shows of Metallica, Elton John, Lionel Richie, and others. Ron StageMaster. No more overloads on stage.